everyone. For today's lesson, we are going to continue our discussion of working with points, lines, and planes, but this time we're going to focus primarily on segments. Day 4's lesson is called The Use of Segments and Congruence, in which our I can statements, our I can apply, the segment addition postulate. It's just like it sounds. We're going to be adding segments together. Next, we're going to use symbols to indicate whether segments are equal and congruent. So certain symbols, whether they are visible or not, indicate that segments are equal, or a new word, congruent. And finally, we are going to identify or be able to find the length of a segment when it is vertical and horizontal, with our language objective being that you can explain whether or not two segments are congruent. All right, before we get started, it's important that you have all of the materials that you need for today. The first thing you need to do is you need to print out the Unit 1, Day 4 video lesson cutouts for the interactive notebook. Once you have print this out, I would like you simply to cut out this box. That is all you need to do. The next thing that you will need is you will need scissors, some highlighters, something to write with, and a glue stick. If you do not have a glue stick, that's okay. Just use some tape. If you do not have a printer to print out the cutout for today, that is okay. Just follow along with what we write in our notebook. All right. If you need to pause the video to make sure that you have all of the materials that you need for the lesson, please feel free to pause at this time. All right, so the first thing I'm going to do is a quick warm-up with you guys. And my warm-up for you is going to be, take a ruler. Now, if you have a ruler or a straight edge of some kind, that might be a good thing as well. I should have probably identified that in our supplies that you will need, but that's okay. I'm looking for you to have a straight edge of some kind. If you don't have a ruler, just anything straight is perfectly fine. And what I want you to do is I want you to identify what is the length of one side of your desk. In centimeters. Now, obviously, if you do not have a ruler with you, that is okay. Just tell me how many times you had to move your straight edge in order for you to find the length, and then kind of make it approximate. So what I'm going to do is I'm going to, on the side, check out what my side of my desk is, and I'm going to start counting it. And I know that it's kind of hard for you to be able to see what I'm doing, but essentially I'm just going one length at a time. So that's exactly what I'm going to do here. I'm just going to measure all the way down the side of my desk, and in my desk it is 94 centimeters. This is Mrs. Olivero's desk. Your number is going to be a different number. So the question is, how were you able to come up with this number? How was I able to come up with this number? I had a desk, and I have a ruler that I'm using, and my ruler is not as long as my desk. My ruler is just this little tiny piece right here. And I would measure it, and then I would measure it again, and then I had to measure it again. And then I had just a little bit more. And order for me to find the length, I don't have a ruler or a measuring device that is exactly 94 centimeters. I had to add and shift it along the way along my desk to get to 94 centimeters. And what we just used here is what we call the segment addition postulate. We used the segment addition postulate to find this length. So that's what a segment addition postulate is. It's where you're taking segments and adding them together to find the whole. Part plus another part is a whole. So in order for us to talk about a segment and its length meaning that it was an actual value, an actual number, let's say that the length of my desk was AB. In order to find the length of AB, or to write it using the language of geometry, we would say that the length of AB is equal to 94 centimeters. Notice that AB has no symbol above it. And when you have no symbol above, that means that you're talking about an actual value. It is a segment that has a number attached to it. It represents, so whenever you see no symbol, like AB in this case, that represents the distance of a segment. Which is a number. Distance is, in other words, length. That is distance right here. Distance or length of a segment is always represented with a number, and there is no symbol above your letters. So when you see no symbol above, we are talking about a value, a length, a number. When you see a symbol above, we're talking about an object or a thing. So distance between points A and B, written as AB, no line above, represents or is the absolute value. Ooh, absolute value. Remember, absolute value represents a positive number. We learned about that in Algebra 1. It is the absolute value of the difference of the coordinates of A and B. There was a lot that I just wrote right there. So what I mean by that, so the distance between points A and B, if we were to talk about this on a coordinate plane or on a number line, in order for you to find the distance between 2 points, A and B, it is written as AB with no line above because distance represents a number. It is the absolute value of the difference. That means that we would subtract two different numbers. We would subtract their difference and be able to identify the distance between them. Absolute value simply means that we are talking about a positive number. So if we were to look at a line with point A on one side and point B on the other side, and if we wanted to identify what is the length of AB, just that piece right there, we would get out a ruler, or we would look at what it says. And in this case, if I got out a ruler and looked at the centimeters, it looks like it's about maybe 2.4 centimeters. And therefore, we would write that as AB is equal to 2.4 centimeters. Coordinates, I just want to talk about. If we were talking about a coordinate plane, remember that coordinates are x, y coordinates. I should have wrote that down a little bit sooner, but that's okay. All right, so the segment addition postulate, writing it out as an actual postulate. Postulate simply means a statement that is always true. So let me define that really quick. A postulate means a statement that is always true. So we're going to have a lot of language like theorems and postulates and definitions that we're going to be working with, and that is simply what a postulate means. It is a statement that is always true. It is agreed upon in the mathematical world that it must be a true statement. All right, so the segment addition postulate in very formal words says that if B is between A and C, then AB plus BC must equal AC. We call that part plus part equals whole. Part plus part equals whole. So what does that look like? So let's go ahead and look in and dive into what this postulate is saying. So the part that I'm going to emphasize is the AB plus BC equals AC. So let's draw that. Let's draw a segment. Let's draw a segment with B being in between A and C. So here's A and C, and somewhere in the middle, not the direct middle, just between. So be careful. Just because a point is in between doesn't mean it's in the direct center. That means something else, and we will talk about that. That's called midpoint. But AB and BC, they might be different lengths. But what this is saying is that AB, whatever the length of AB is, this is a part of the whole segment. So this part and this part, when added together, BC, would together connect to equal the whole. The whole length of the segment. Part plus part equals whole. So we have right here, this length is AB, this length is BC, and together the whole thing equals AC. Part plus part equals whole. All right, let's go ahead and flip the page. And now we're going to talk about a line above versus no line above with a word, with our cutout. And that is talking about an idea called segment congruence versus segment equality. So what I would like you guys to please do is I would like you to please take your cutout. I have mine in yellow. And I'm going to fold it in half twice. So I'm going to fold it, I think they call this hamburger style. So I'm going to fold it hamburger style and draw a crease. Then I'm going to fold it up one more time and draw and make a crease again. I'm just going to open once so you have like this fold line, and I'm going to take my scissors and just cut once, because what we are going to make is right here. Lengths are equal, lengths are congruent. We are going to make this cutout so that you can see right here there's no cuts, but up here there is a cut. So that is the cutout that we are going to create. All right, so I'm just going to cut right up the line. And there we go. So now you should have your cutout looking like this. All right. So what we're going to do inside is we're going to talk first about lengths that are equal. Lengths or numbers are equal. What that means is that if I have two segments, and what I want you to do is up here, I want you, with your straight edge, to draw two segments that are about the same length. Leave a little bit of space in between. We're going to call this first length AB. Or this first segment is going to be AB, and this second segment is going to be called CD. These two segments are congruent, and one way that you can say that they're congruent is we already know that they have the same measure, but you would see a symbol, like a tick mark, that's called a tick mark. And I think that you might have already seen some of these before, but this is called a tick mark. And tick marks indicate, like if you have like two tick marks on one segment and two tick marks on another segment, those two segments have equal length. If you see one tick mark on a segment and two tick marks on another segment, they're not congruent. So the number, you kind of match up the number of tick marks to see if something is congruent. In this case, I made sure that length AB and length CD had the same length. So I can say that length AB is equal to length CD because when I measured it out, they both had the same length. And we have no symbol above, so this means a number is equal to a number. We call this is equal to. AB is equal to. CD, there is no line above because we're talking about a number. And that number that we're referring to is the actual visible length. And in this case, I made this, I want to say it was like 7 centimeters. In this particular problem, it was 7 centimeters and 7 centimeters. Just to make sure that I had mine the exact same. But what if you didn't know the length? Or what if you didn't care what the length was? You just knew that they had the same length and you wanted to talk about a relationship. So we are more interested into the relationship between the two segments or the two shapes or the two figures. If we're just interested in the relationship and how something is related, and we're not interested in a number, so we're not referring to a number. Because that's not what we're talking about or interested in. What you would say instead is segment AB with the symbol above is congruent to segment CD. This means that they have the same length, but I'm not interested in talking about numbers. I'm interested in talking about their relationship. The congruent symbol is very similar to the equal symbol, but it just has a tilde above it. And what this symbol means is congruent to. And if you're talking about congruence, you must have a symbol above. If you don't have the symbol above, then what you're saying is that a number is equal to a number, which is super awkward. No, I'm sorry, excuse me. You're saying that a number is congruent to a number. Never have we talked about congruence in that respect before. Numbers are equal to each other. Things can be congruent to each other in terms of a relationship where you're not interested in the number. And that's what this tab is right over here. We're going to close this and call this segments are congruent. All right, I am done with this cutout and I am going to paste it up here. And we just have a couple more things that I want to write down and note so that we're all on the same page when it comes to this idea of segments and congruence. So if two segments, the thing that I want you to know is if two segments are congruent, then they have equal lengths because there is a relationship between what we're talking about here. So I want you to note that if two segments are congruent to each other, that means they have the same length. If two segments are congruent, then they have equal lengths. And vice versa. If two segments have equal lengths, then that means that those segments are congruent. So congruent is just saying that they have a relationship. They have equal lengths. We don't necessarily know what those lengths are, but we just know that they are congruent, so they have equal lengths. We would use a congruent symbol until we know what the actual numbers are. So that is one way to view it, and the other way to view it is if two segments have equal length, then they are congruent. So the reverse is true. This is what we call a converse, the reversal of a statement. If two segments have equal length, then they are congruent. If two segments are congruent, then we have equal length. It just depends on, do you know the length first or do you not know? Are you more interested in symbols? So the question is, when do you use each symbol? That is a really big question, and I'm writing it down really, really big because this is key. This is really important. When do you use each symbol? This is big. We need to make sure that we feel comfortable with when we're going to use this. So you're going to use the congruent symbol. Which once again, the congruent symbol looks like this. You're going to use the congruent symbol when describing a relationship. Between geometric figures. So, for example, something you might see would be two segments that are congruent. So I'm just going to draw two segments equal in length, and you're going to see a symbol on each one. And I'll call this H, I, J, and K. And we would say that segment HI is congruent to segment JK. If we're talking about another shape, like a rectangle, for example, and we know that in a rectangle, we have two sides that are going to be congruent to each other, and the other two sides are not congruent. And I'll call this A, B, C, and D. In a rectangle, I know that opposite sides are congruent, but not necessarily all sides are congruent. So in a rectangle, I would say that segment AB is congruent to segment DC. That's a relationship. I'm not interested in what the exact length is. I would also say that segment AD is congruent to segment BC. It's a relationship. I'm just going to put the right angle symbol in there just to say that we're talking about right angles. So that is when I'm going to use the congruent symbol. I don't have any numbers on here. I just want to talk about a relationship. You're going to use the equal sign when you see something like this. So you're going to use the equal sign when describing the actual length. Which means that we're talking about an actual number, but the actual length of geometric figures. And what that looks like, if we're going to use our examples up here, is we'll have two segments. Once again, HI and JK. But now we're interested in what their actual length is. And the length in this case is about, looks like about 1.5, and it looks like about 1.5. So 1.5 centimeters and 1.5 centimeters. So we would say HI is equal to JK because we are talking about a number. That is 1.5 centimeters is equivalent to 1.5 centimeters. Numbers. I'm interested in numbers when we're using equal sign. Up here with congruence, we had no numbers. If we're looking at a rectangle, we'll call this A, B, C, and D again. We know that the opposite sides are congruent, but we would actually be interested in how long each side was. This looks like it's about 1 centimeter long. And on this side, it appears to be about 2 centimeters long. So 1 centimeter by 2 centimeters. So we would say that segment AB is equivalent to segment DC, and AD is equal to segment BC. And we would say that because these all equal either 1 centimeter or 2 centimeters. We're talking about actual numbers. That is the end of today's lesson. So we talked about two things. We had the segment addition postulate, where that means part plus part equals whole. And then we also talked about segments congruence versus segments equality. If you have any questions about this lesson, please feel free to email me. Otherwise, I hope you have a wonderful day.